Now let's take a second look at the same section of point 5, but this time we're going to look at some word problems and systems of 3 equations. So for word problems, the ones we're going to look at is just still with 2 variables. Please make sure you're using that 5-step plan. So the first step, do what you need to do. Underline key important information, draw a picture if you need to, etc. But then let's make sure to define our variables, create our equations, solve, and of course, state your answer with a label. So for number 1, it says Joe received $1.20 in change out of nickels and dimes. The amount of nickels he has is 4 less than twice the amount of dimes he has. How many of each does he have? So key thing, $1.20, right? And the nickels he has is 4 less than twice the dimes. So let's define our variables. We're looking for nickels and dimes. Whatever letters you want to use, doesn't matter. So if X represents the number of nickels, and Y will represent the number of dimes. Now, because I have 2 variables, it means I need to come up with 2 equations. So altogether, I know we have $1.20. Now remember, it's not going to be that X plus Y equals $1.20 because X and Y represents the amount of nickels and dimes we have. What we need to remember is how much a nickel is worth and how much a dime is worth. So for example, a nickel is 5 cents. So we can write this as 0.5x plus 0.10y equals 120. Okay? Our second equation will deal with the other underlined part, the amount of nickels he has. So nickels is, so X equals 4 less than twice the dimes. So 4 less than twice the dimes means 2y minus 4. Now I have my 2 equations, so I can go ahead and solve. Well, this is already solved for X, so a good method to use would be substitution. So I'm going to take what I just found X to be and substitute it in for X for my other equation. To make life a little easier, I'm going to clear the decimals as well. So that equation is going to really be 5x plus 10y equals 120. It'll just make it a little easier. Now I'll substitute in. So we'll have 5 times 2y minus 4 plus 10y equals 120. Distribute 10y minus 20 plus 10y equals 120. Combine my like terms, that gives me 20y. Add 20 gives me 140. And now divide through to get y alone. This will tell me y equals 7. Now that I know y, I can go ahead and find x. So x equals 2 times 7 minus 4, and that will give me 10. So what does this mean? Joe has 10 nickels and 7 dimes. And let's think about, does that make sense? 7 dimes is 70 cents, 10 nickels is 50 cents, and 70 cents and 50 cents makes $1.20. There we have it. Okay, so you try number 2. Read the scenario, make sure to define your variables, write your equations, solve, and then state your answers, just like I did with number 1. All right, the second half of the notes is on systems of 3 equations. So this time around, we're not just looking for x and y, but we're looking for 3 variables, x, y, and z, most commonly used. Remember, they can be a, b, and c, any letters that you want, but most commonly we'll have x, y, and z. If I'm looking for 3 variables, it means I must set up 3 equations. Now, 3 variables is no longer in our coordinate plane. What we have here is 3 dimensions. So we have planes. And if we look at our images below, there's 3 scenarios. We can either have a single solution, which we call an ordered triple. And if you look at the image, it's where all 3 planes intersect just once. So we have a single point, which is our ordered triple. We could have infinitely many solutions, and there's two scenarios for that. The first one is where all three planes intersect as a line. Remember, planes go on and on forever, so as they intersect in a line, that goes on forever. So we have infinitely many. Again, not all real numbers, but infinitely many. And then the more obvious one is if all three planes are the exact same thing and they are on top of each other, that means we overlap in all those places. So again, infinitely many solutions. The third scenario is no solution. Now pay careful attention to this. We could have some intersections. However, remember, a solution is where all three planes intersect. So in our first two examples, we have solutions amongst two planes at a time, but never amongst all three. And clearly the last example, none of them intersect, so clearly there are no intersection points and no solutions, okay? So how do we solve these? I'm gonna do two of them with you and have you practice two of them on your own. Our goal for solving systems is to actually create a systems of two equations. So you're going to choose a variable to eliminate. It doesn't matter, you just want to make life easy. So my intentions for number 3 is to eliminate z. And the reason I'm doing that is because in the first two equations, I can see that z's are already opposites. So I'm going to keep myself organized. I'm going to group the first and second equations together. So I'll have x minus 2y plus z equals 15, and 2x plus 3y minus z equals 7. So I just rewrote those. Make sure to be super careful with signs, with operations. Double check your work constantly because one tiny mistake will throw off everything, and then that's just frustrating. So if I have these two equations and my goal is to eliminate z, they're already opposites, so I'm just going to add the two equations together. That gives me 3x plus y equals 22. So now I have an equation with two variables. My goal is now to group another pairing of the original to get x and y. So I paired first and second. Now I either compare first and third or second and third. I'm going to pair the first and third together because they're already opposite signs. However, to get z's to be opposite coefficients, I need to multiply that first equation by 5. So when I do so, we get 5x minus 10y plus 5z equals 5 times 15, which is 75. The third equation I will leave as is, 4x plus 10y minus 5z equals -3. Now, this is going to be awesome because when I put these together, I get 9x equals 72. The x and y, the y's and z's both canceled. So I'm just left with 9x equals 72. At this point, I now have a system of just two equations. And this is, like I said, an even easier system because one of them only has one variable. But I'm going to group them in a process so that if you don't get as lucky, you can still follow along. So here are my two new equations I've created. Often they'll have two variables. So now at this point, you either use substitution or elimination. For our case here, we know that, well, back to blue, we can solve this 9x equals 72. So if 9x equals 72, x will be 8. Now I can take that and plug it into the other equation. 3x plus y equals 22. I'll plug in the 8. This will allow me to determine what y is. So we get 24 plus y equals 22. So y will equal -2. Last but not least, we need to find z. So how can I find z? Go back to one of the original equations. I'm going to use the first one because it has the least amount of numbers and work to do. So it says x minus 2y plus z, x minus 2y plus z equals 15. And I'll plug in what we've gotten for x and y. So that means 8 minus 2 times negative 2 plus z equals 15. This will become 12 plus z equals 15. So that means z will equal 3. Therefore, I get a solution. It's an ordered triple, and I'll write that x first, y second, and z third. And there is my solution to the system. Always go back and double check by plugging them in. So if I plug those 3 values into the first equation, we get 8 plus 4 is 12 plus 3 is 15. That's good. The second equation, 2 times 8 is 16, minus 6 is 10, and 10 minus 3 is 7. That's good. If I plug it into the last equation, we would get 32 minus 30. Minus 20 is 12, and then 12 minus 15 is negative 3. Awesome. So it definitely checks out. I'm going to now do number 5 with you, and then I'll ask you to go back to do 4 and 6. So if we look at number 5, we're going to start the process the same way. We start by deciding on one variable to eliminate. And in this case, the x's look easier to me, right? If I look at the x's, we already have a pair of opposites. So I'm going to start by eliminate the x. So I'm going to group second and third equation because I already see we have a pair of opposites. So negative x plus 3y minus 2z equals negative 1, and x minus 2y plus 3z equals 1. When I add those together, our x's cancel. We have 1y and 1z, and that equals 0. And that's okay to have that equal 0, right? The variables all didn't cancel out. So we have y plus z equals 0. Now I'm going to group another pairing. So I think I'm going to pair the first and second. To have those x's eliminate, I need to multiply that second equation by 2. So our first equation is 2x minus 4y plus 6z equals 5. And our second equation will now be negative 2x plus 6y minus 4z equals negative 2. I'll put those together. X's cancel. I now have 2y plus 2z equals 3. So at this point, I've created 2 equations with the same 2 variables. So I now have a system of 2 equations, y plus z equals 0, and 2y plus 2z equals 3. I'll now solve this, your choice, substitution or elimination. It really doesn't matter. I'm just going to use elimination. So if I use elimination, I'm going to multiply that top equation by negative 2. This will give me negative 2y minus 2z equals 0, and the bottom equation we leave as is. I'll put those together, and what happens here? Our variables cancel, and I get 0 equals 3. When that happens, this is a false statement. So what does that mean? That means that there is no solution to this system. Now, I'm going to have you guys try the other 2. I'll give you a hint. One of them comes out as a nice ordered triple, and another one is a special case. Okay? So go ahead and try that and finish up those notes.